the following molecules are, and then we've got a list of possible relationships we could have between these two molecules. So they could either be the same as each other, they could be mirror images or enantiomers, they could be diastereomers, or they could be constitutional isomers. And so the last example we looked at, we were identifying an enantiomer, and it was kind of easy to do because the molecules were oriented the same way. And so looking at these two structures, hopefully you can see that they have the same connectivity. So if you were to number the chain like you're going to provide the IUPAC name, so I'm numbering it to give the alcohol the lowest possible number. So this would kind of be the first thing to check to see if they are connected together the same before we even worry about stereocenters. And they are. So these are both 4-methyl-2-hexanol. Right, so that part of the name is the same, so they are not constitutional isomers, or else there'd be something different in that part of the name. So what you can do, you can assign all the chirality centers if you want to and compare, because if they are enantiomers, both of the chirality centers at 2 and 4 would invert, right? If they were diastereomers, they wouldn't be exactly mirrored. Another thing you might want to do that might be a little bit faster might be to redraw one of these molecules. So if you take this one and think, oh, I'm going to flip it over. So if you flip it over like that to reorient it, then you'll have the chain the same way. But when you flip this over, anything that's sticking out is going to end up going into the plane of the page. That means the alcohol would end up going into the plane of the page when you flip it over, and so would that methyl group. So when you draw it like this, it might be easier to see what the stereochemistry relationship is, because now we can see that the chirality at that alcohol center, at that carbon 2, is not changed, but the chirality at carbon 4 is. So these are not mirror images. But they are stereoisomers. So any stereoisomer that is not a mirror image is a diastereomer. Okay, and if we want to see what the enantiomer would look like, is you'd have to invert both of those chirality centers. So if you did want to draw the enantiomer, that means you'd have to draw the structure where the alcohol is now coming out, and that methyl group would be going back. So that's what the enantiomer would look like.